Hi guys, so this was the results from our contagious lab. My group of 8th graders today did this experiment on their own. What they did is they pretended that one of their classmates had a disease. They had stickers. As they would mingle, the classmate handed out the stickers, and then those people who got stickers were infected. We modified the experiment by including some vaccinations towards the end, so our results show that too. So mingle 1 and 2 were normal. There were no vaccinated people. We started out with 1 infected individual, and then after the mingle we had 2. For our second mingle, we started out with 2 individuals who were infected, and then, and then after the mingle, we had 4 infected individuals. Then at mingle 3, we decided we were going to vaccinate 20% or 2 of our classmates. So 4 infected people were infected, but 1 of them was vaccinated, so really only 3. And then after the mingle, we had 9 people. 9 people were infected eventually, so our whole class, but 2 of them were vaccinated, so really only 7 of them caught the virus. Then for mingle 4, we started off, we had 40% vaccinated, so that's 4 people. 2 people were considered contagious, so they went out, they mingled, and then afterwards our result was 6 total people came in contact with those infected people, but because 4 of them were vaccinated, only 2 were sick. In our very last mingle, because we weren't able to do 6, we didn't have enough people, we vaccinated 60% of the population, or 6 people. 2 people were infected, 6 were vaccinated, and then they mingled, and then 6 people were contacted. All 6 of the vaccinated people came in contact with the 2 infected people, but at the end 0 became infected. So those are your results. I was going to have you guys chart this, but you aren't able to edit this, so this would have been if you were sitting here with paper and pencil, but that's not how we're doing things this year. We're doing them virtually, so it's a little more difficult, so you won't be able to do this graph, but if you were, after mingle 1, 1 infected person, or 2 infected people, then you would have 4 infected people, then you would have all 9 infected, right? So you would do bar graphs. Here's some discussion questions. We talked about them as a class, so I'll talk with you right now about them. So discuss what happens during each mingle as more students are vaccinated against the virus. So we see that as we started vaccinating more and more people, less people became infected with the disease. So as more people are vaccinated, less people are made sick by contact with an infected person. A vaccination does not stop you from coming in contact with an infected person, but it does, however, stop you from contracting whatever disease they had that you're vaccinated against. So if I came in contact with somebody with chickenpox, because I've been vaccinated for chickenpox, I won't get the chickenpox, but that's not going to stop me from coming in contact with them. What are some other methods of preventions methods we could use to prevent the spread of illness? This is very applicable to us today with everything that's going on with COVID. So we have vaccines, we have masks or personal protection equipment like masks, face shield, gloves, gowns, all of that good stuff. We could quarantine people, we could isolate the sick people. Some of our classmates talked about the 6-foot rule, so making sure that we're giving people personal space, and then you could stay at home when you're sick. Number 3, you're going to do on your own. So of the methods you listed above, which do you feel is the most effective? So please tell me which one and explain why. And then the very last one asks, how does the time it takes an infected person to show symptoms after the spread of illness? So how does the time it takes for an infected person to show symptoms affect the spread of the illness? What I want you to think about is, say I was infected, or say one of the students was infected here in science class, but they didn't show symptoms till band class, right? So they go through math and band class without knowing that they're sick until the end of band class. That's when they start feeling bad. But they were infected and able to spread the disease starting in science class. How many interactions do you think that they would have in math class and science class before they knew they were sick? So how many people do you think they were infecting without knowing what was going on, that they were sick? So this is really applicable again with COVID, because you start showing symptoms 3 to 5 days after, but you can start spreading COVID even before that. So that's why it hit us pretty hard, because we didn't know we were infected until it was too late and we'd already come in contact with all of those people. That's why quarantine was one of the more successful of the strategies that helped us kind of decrease the numbers of COVID that we have. So if you have any questions, let me know. If not, type these up and get your data in there. Make sure you're sharing. Make the link visible for everyone. Anyone with the link, if you need to change it, you go to change. You click the arrow. We want anyone with the link. Done. Copy, and then put it into your assignment on Canvas. Have a great day, guys.